Hello, good morning. Can you able to hear me? Can you able to hear me? Can you please confirm that? I hope yes. Okay, let me share my screen. Let me share my screen before going further. Let me close this one. And yeah, yesterday we have discussed about many things actually, like introduction to course and introduction to syllabus, what we are going to do, and we have discussed about what is an application, what is a server, what is a what is DevOps and SDLC process, where does uh, Docker and Kubernetes fits in SDLC process, and we have discussed about the virtual machines, like physical machines. What will happen, what are the disadvantages that we have if we deploy our applications on physical machines? Because of the disadvantages, we are going to deploy the applications on the virtual machines. And what are the disadvantages that we have if we deploy our applications on the virtual machines? Because of that disadvantages on the virtual machines, we are going to Docker. So we have discussed all these things, and also we have discussed Docker terminology. What is Docker host, what is Docker container, what is Docker image, what is Docker daemon, what is Docker client. All this Docker terminology also discussed yesterday. And we have installed Docker in the EC2 machines, and also we have discussed how, we have discussed how to create EC2 servers, and how to create a key pair, how to create EC2 machines, and how to install Docker. All the things we have discussed in the yesterday's class actually. Now, what we are going to do in the today's class is we are going to discuss about the one second, let me go to here, the architecture of the Docker actually. Now let me select the entire things. Let me select the entire things. Okay, the architecture of the Docker. Now, how the Docker has been architected actually. Now, let's see that one by one. Now, let me put it here, Docker architecture or architecture. Now, in the Docker architecture, we have three main components, actually, three main multiple components, I mean to say, but three are the main. Okay, one is Docker client. Okay, this is the Docker client. Okay, this is the Docker client. Let me take this as here, Docker client. Okay, this is client. Okay, this is the Docker client. What is Docker client? Yesterday we have seen from where we are executing the commands is Docker client, and we have Docker host. Okay, let me take this one and let's go here, and this is the Docker host, we call it as, and this is the Docker host. And let me go here, and let me go here, Docker. This is the Docker host actually. This is the Docker host. Okay, now the third component, the third main component that we have in the Docker architecture is Docker registry. This is the Docker registry that we have. Let me put it like this. 1 second. This is the Docker registry that we have. Okay, now inside the Docker host there will be a Docker daemon running. Okay, there will be a Docker daemon running. 1 second, let me put like this. 1 second, let me put it here like this. There will be a Docker daemon running inside the Docker host. Now, this is our Docker setup. Now, let's go to my Docker local machine. Okay, my where I have. Let me go to my Docker host. Now, let me execute. Let me execute the Docker related commands from here. Actually, now let me go here and Docker images. Okay, Docker images. Let me go here and execute the images part here, and let me remove all the images. Do not mind that. Okay, Docker system prune -a. Let me remove all these things. The images got removed, some of the one, and Docker rm-f. To see, we'll discuss all the things. What are all these? But yeah, let me clean up my workspace. Okay, now Docker ps-eq. Let me remove this. Okay, now Docker system prune -e. Let me remove all these things, and yeah, I have removed all these things. Now let me clear the screen. Let me clear the screen. Now I am executing. See some of the Docker commands. Okay, some of the Docker commands. Now first command that you need to know is Docker images. Okay, Docker images. Now this is the Docker images command that represents list all the Docker images present in your Docker host. Okay, that is the list all the images present in your Docker host. Now when you execute this command, what is actually internally happening? What internally actually happening? So let's see that one. Now let me go to paint here and let me click on this one. I am executed from the Docker client. I've executed Docker images. I've executed this command, right? Control minus, I've executed this Docker images command. Actually, what internally happened when you execute this command means that this command is listened by the Docker daemon. This command is listened by the Docker daemon, like this Docker daemon. Now Docker daemon listened to this command Docker images. Okay, Docker images that we have executed on the Docker client. Now this command is listened and Docker daemon will be performing the necessary action. Here, what's the action it should perform based on our request using Docker images command? It should list all the images present on my Docker host. That is the action that it should perform. That action it have performed like that, and it has listed this. That means the images were not present. So Docker images will be for the listing of Docker images command will be for the listing of Docker images on the Docker host. Actually, now that's the thing. That's the ultimate thing. Okay, now, if you want to pull any Docker image, now what is the command I need to use? Docker pull Nginx. Nginx is the image name that I need to use. That is the Docker pull Nginx is the image name that will pull the image Nginx from the hub.docker.com. Okay, let it complete. Okay, let it complete. Now, if you see Docker images, that means this is the Docker image that has been pulled from the hub.docker.com. Docker software is automatically configured to pull the images from the hub.docker.com actually. So that's the thing. If you observe, if you pull the image, it will give the image name, the tag to that image. What tag represents is different version of the same application, of different version of the same Docker image. That's a tag. Now this is the image ID that we call it as, and when it is created 4 weeks ago, it has created in the 4 weeks ago, and size of this image is 192 MB, actually 192 MB. Now we have executed this command Docker pull. What is the command we have executed? Let me put it here. One second. Docker pull Nginx. Docker pull Nginx. Let me go to top here and let me increase this box like this. We have executed Docker pull Nginx. That means this command is listened by Docker daemon. Okay, this command is listened by Docker daemon, and Docker daemon connected to Docker registry to pull the Nginx image from it, actually to pull the Nginx image, and it have downloaded, it have found the Nginx image here, actually Nginx image in the Docker registry, and it has downloaded the Nginx image to itself, like on the Docker host, like this it has downloaded like this. One second. Yeah, on the Docker host it has downloaded the Nginx image. Nginx, okay, the Nginx image, it got downloaded on the Docker host. Now this is how when you that is how the command runs when you run docker pull nginx. If you run the command docker pull nginx, that will connect to docker daemon. Docker daemon will be connecting to docker registry. Docker registry it will find the image in the docker registry and downloads the image onto my docker host. That's how it works internally when you execute docker commands. Now I want to run this nginx image as a container. What is a container? The running instance of an image is called container, that we have seen in the yesterday's class. If you are not sure, if you are new to the class, please go to the yesterday's video or yesterday's recording in the YouTube and you can find the things there. Now go here. Now how to run this nginx image in the as a container. Now how to run that? Docker run hyphen name is equal to web app. Hyphen name represents I am giving a name to container. I am giving a name to container. Hyphen D represents the detached mode. Hyphen D represents the detached mode. And hyphen P, okay, hyphen P represents the port mappings. As of now, no need of using hyphen P. Now, nginx. What is the detached mode? I'll tell you in the future classes, but as it's not time to explain about this hyphen D, you need to use hyphen D, and the nginx is the image name. Just click on enter. Now, Docker container ls, this is one command. Docker container ls is a command to list all the running containers. How you will be able to know it whether it is running or not? By using the status. Here it is an up state, that means it is a running container. Here we have used another command to run nginx image as a container. In order to run the nginx image as a container, we have used docker run hyphen name web app hyphen d nginx image name, something like that. Now let me go to there. Okay, let me go to the paint. Now what happened when you execute this docker run command? Let me go here and let me put it here. Now what we have used, docker run hyphen name is equal to web app, and I've used hyphen d, and I have used one second. I have used hyphen d and have used nginx is the image name. What happened when I use this nginx as a thing? Actually, now it got connected. It got connected to docker daemon. This command which we executed from the docker client got connected to docker daemon, and docker daemon found the nginx image on the docker host. Nginx image on the docker host, because docker daemon finds this we are using nginx image to run it as a container, and it has found the image on the docker host because it's previously downloaded when you execute this docker pull nginx command. Now this will run, this image will be executed as a container like this. This image will be executed as a container like this. Okay, one second. This will be executed as a container like this. Okay, something like that. Okay, now that's how it works actually, because the nginx image is there here. That is why it is running as a container with the name web app, because I'm using the name as web app here. Okay, in the command, while executing the command, let me use web app. Okay, that's a web app container in which the nginx application is in running state. Now let's also run the Tomcat. Tomcat is a web server. Let me take docker run. One second, where is that? One second. Docker run hyphen name is equal to web server. Okay, hyphen one second, please. Hyphen d I want to use. I will tell you what is hyphen d. Please do bear with me. As of now, you don't need of knowing about the hyphen d because it's not a time. Okay, docker run hyphen name web server, name of the container. This is the name of the container. Okay, hyphen name represents. Now hyphen d is the detached mode that I will explain in the future classes. Now I want to use Tomcat image. Tomcat is the image name that you want to use. Actually, that's a image name that you want to use. Now click on enter. Docker run hyphen name web server hyphen d Tomcat. Click on enter. Now let's see. it is unable to find the Docker image locally. It is unable to find the Docker image locally because Docker image is not pulled previously. Now let it complete. It is trying to pull the image and run it as a container. Okay, run it as a container. Let it complete. Now, if you see docker container ls, this docker container ls is a command to list all the running containers, actually to list all the running containers. Now, let me go to the architecture. Now, what I've executed, let me put it here as well. Now, when you execute that command, docker run command from the Docker client, let me put it here. Let me put it like this and put it here. Now, what I have executed, docker run hyphen name is equal to web server web. Once again, what is the name I have used here? Web server. Okay, web server hyphen d, and the Tomcat is the image name that I have used, right? So this is the thing that I have used. Now, when you execute this command is listened by the Docker daemon. This command is listened by the Docker daemon. Okay, this command is listened by the Docker daemon, and Docker daemon has not found the image on the Docker host because we did not pull previously. We have in the Nginx case, we have pulled this image previously, Docker pull Nginx, but in the case of Tomcat, we did not pull the image previously. What it will do, if the image is not there on the Docker host previously, it will connect to Docker registry where we store all the images. Let me put it here. Tomcat. Okay, this is a Tomcat image. It will connect to Docker registry, something like this, to the Tomcat image, and it will download the Tomcat image. It will download the Tomcat image here. Okay, this is the Tomcat image. Tomcat image it will download, and this Tomcat image will be executed as a container. Let me put it here. One second. Okay, web server. Okay, this is the Tomcat image that will be executed as a one second, let me remove this. Now this is the Tomcat image that is executed as a container. Now, what you need to understand from these two different commands, these two different run commands, is if the image is present on the Docker host, that will be used as a that will be used to run it as a container. But if the image that you are using to run as a container is not present on the Docker host, it Docker daemon connects to Docker registry and create a container out of the image, actually, which is present in the Docker host. So that's is the Docker architecture that we have, actually. So this Docker registry may be a public or private registry. That's none of our matter, but yeah, that Docker daemon connects to that registry and perform the downloads and perform the downloads of the images from the Docker registry to the Docker host and run them as a containers. Actually, this is how the internal functionality will happen between the Docker client, between the Docker client, Docker daemon, and Docker registry, actually. So Docker host as well. So that's a Docker architecture that we have that you need to understand before moving further. Any questions anyone has, please? Okay, if no questions, let's move further to execution of some commands on the Docker. Actually, let me decrease the font size. Let me clear the screen. Now, let me clear one more time. Clear once again. Now, if you see, I am executing Docker. One second, where is that? Docker container, container ls. Okay, this is the two different containers that were being executed. Now, if you want to use this container, let me remove the container. How to remove a particular container which is in running state is using docker rm -f and the container ID. You can use this command to remove the running container, and -f represents force. Okay, you should forcefully remove the running container. Okay, now rm represents the remove. Okay, this is a container ID. Each and every container will be having some ID. Okay, that is a container ID. This is a container ID to remove that. Now, how to remove this container? Now, how to remove that? Docker rm container -f and the container ID is the command. Now clear the screen. Okay, docker container ls. There is no containers that is running. Actually, what we are seeing, how to remove the container, docker rm -f is the command. If you see docker images, if you see the docker images, there are two different docker images. Okay, now you in order to remove this docker image, docker rmi, you need to use tomcat. Rmi is the meaning full form of remove image. Rmi is the full form of remove image. Now click on enter. That image will be removed. And if you copy the other image, now docker rmi nginx is the image name. This is how you need to remove the images. Now, if you have multiple images, suppose you have 100 or 50 images, 50 or 50 to 100 images, you cannot execute all the rmi image 1, rmi image 2, docker rmi image 3, something like that. It takes huge time. You will be having some command docker system prune -a. Okay, docker system prune -a. You need to execute it. It will ask for confirmation. Click on y and click on enter. It will be removed all the images. Actually, as of now, there is no images. Now, if you use docker pull nginx, nginx, I want to pull this first. Now I want to pull the tomcat. Okay, let me pull the tomcat. This is the downloading of the image. Docker pull tomcat means it's a downloading of the image from the Docker hub, actually hub.docker.com. That's the thing. Let it complete. Now, how to see? If you see docker images, these are the two images that are present on my Docker host. Now, sorry, docker, how to remove all the images at once? Docker system prune -a is the command that will remove all the images at once. Click on y and click on enter. So you can remove multiple images at once. Actually, let me clear the screen. Okay, clear the screen. Now, how to access? Suppose I am running the nginx container inside nginx application inside the container. How to access that application from the browser? Actually, now let me do that. Let me use port for. There is something called port mappings. Actually, how to do that? Docker run -name is equal to web app -d -p. Let me go here and minimize this. Okay, -p. 1 second. Okay, that's -p. -p, I'll tell you what is -p. 9999:80 and nginx is the image name. Actually, now click on enter. Okay, now unable to find the image locally. It is trying to download the image because just now we deleted the image here. We're using this docker system prune -a that will remove all the images. Actually, now let it download one more time. Now, if you see docker container ls, if you see the docker container ls, this container is in running state, actually, which is on port number 9999. What is this -p 9999:80 represent? If you go to the diagram, let me show you as a diagram that one. Now let me go here. This is your docker host. This is your docker host. Inside the docker host, my docker container will be running. This is the docker container. Okay, this is a docker container. Now, in each and every application inside the docker container will be running on particular port. Actually, suppose let's think, just for example, so Nginx will be running on port number 80, Tomcat will be running on port number 8080, MySQL application will be running on port number 3306 inside the container. Like that, each and every application which is running inside the container will be running on particular port. Actually, here as we are using the Nginx as an Docker container, that Nginx application will be running on port number 80. Okay, now inside that container actually, so this is the application that will be in running the process, it will be in running state, something like this. So in running state, something like this. Now, what is -p? We have used -p 8888:80. Now, what is we have used? Docker run --name is equal to web app. Okay, I'm giving the name to the container. Now increase this one and -p port mapping 8888 and :80. Okay, -t. I've used this in Nginx is the Nginx is the image name. Now, what is this -p 8888:80 represents? 80 represents the container port on which the application is running, and the 8888 represents the host port, the Docker host port. Let me put it as, let me name or label it as Docker host. Let me put it here. Docker host actually. Let me label this one like this. Now, 8888 port represents the Docker host port. This is a Docker host port that is mapped to the Docker host actually. Now, 8888. Now, this mapping, if you use -p 8888:80, this mapping will be happening. Okay, 8888 EIT mappings will be happening. If you want to access this application from the browser, now what you'll do, suppose let's think this is a Chrome browser and you will be connecting to your Docker host with the port number 8888, and on the port number 8888 is mapped with the container port 80, and the request goes to the application, something like that actually, something like this. Okay, once again, like this. Okay, now something like this actually, 8888:80. Now let's access that application from our web browser. We have port forwarded on 9999 here, but it's same as 8888. You can use this port, any port, whether it is 8888 or whether it is 9999, any port you can use on the Docker host, this one. But on the container, you should use port number 80 only for Nginx, because Nginx application by default will be running on port number 80. You cannot change that. Okay, now let me access the application from the browser. Let me go to the browser here. Now let me go here, localhost 9999. Okay, now you are able to access the application which is running inside the container on my Docker host. This is how you will be accessing the application which is running inside the container actually. So something like that. Okay, any questions you can ask? Okay, if no questions, what I can tell you is, let me go again to the back to the paint. Now, let me use another container, Tomcat, and access that application from the web browser. Let me clear the screen. Now, Docker run -name is equal to web server -d detached mode -p. I want to map 7070 port to Tomcat will be running on port number 8080. Okay, Tomcat actually, something I want like this. I want to run, just execute. It will try to pull the image because the image is not present on my local machine, on the Docker host, I mean to say. Now it has been pulled the image. Now if you see Docker container ls, this is the command to execute the image as a container. Now that has been port forwarded on 7070. Now if you want to access this application on the here, once again, localhost. Yeah, this is the Tomcat application which is running inside the container. This is the Tomcat default page that will be running inside the container. Actually, you are able to access this application from your web browser. Okay, now that's the thing. I want to run another container named Jenkins. Okay, how to run that? Okay, Docker run hyphen name is equal to CICD. Let me take the name as CICD hyphen D hyphen P. Okay, now on which port the Jenkins will be running? Jenkins container will be running on port number 8080. I want to map that with 9797 colon 8080 and like Jenkins. Okay, Jenkins slash Jenkins actually. Now this is how you need to run hyphen P represents port forwarding. What is the port forwarding? You are mapping the container port to the Docker host port like this. Okay, this is a port forwarding. I've just told you this is a port forwarding that is there. There's a port forwarding that we call it as you are mapping the container port EIT to the host port, Docker host port EIT. Here also you are mapping. One second, where is that? One second. Yeah, here also same. Okay, 9797 of the Docker host port you are mapping to EIT of the Docker EIT of the Docker container port. Actually, so that's how it works. Actually, now click on enter. Okay, it is trying to pull the image because the image is not present in my local machine. That means my local laptop. Now, if you use Docker container ls, you can see the Tomcat image is Jenkins image is running actually, and Jenkins container is running, and it is port forwarded to 9797. Let me go here and to 9797. Let me use this here localhost 9797. Your Jenkins screen is opened. Okay, your Jenkins screen is open. Let me go here. Now, if you go to Jenkins, let me copy this. Okay, Docker, you need to get the password in order to, it is asking for password. It's an initial administrator password that will ask you to get the password. Docker logs, the container ID, it will be there in the logs of that container. Just click on enter. This is the password. Please use the following password to proceed to installation. Installation actually, just use this password. Okay, now go here and put it here and click on continue. Now click on install suggested plugins. Okay, that will install the suggested plugins that is there. Okay, that is how you need to map port forwarding with your Docker host and to your Docker containers actually using hyphen P actually. So that's how it works. Now we have another flag that you need to know is hyphen E. Okay, hyphen E. Let me clear the screen. Hyphen E represents the passing of environmental variables to your container. Now Docker run hyphen name is equal to mydb hyphen d hyphen e is the passing of environmental variables to your container actually. So environmental variables means like it's like a external variables you need to pass to your application so that your application will be functioning as expected. Actually, suppose your application is there that need to be connected to your Spring Boot your database. You need to pass the database username, database password, database URL in order to connect to the database, right? So in the same way, those are called environmental variables. If you want to run MySQL as a container, MySQL is a database. If you want to run MySQL as a container, you need to use environmental variables. Actually, what's the environmental variable? MySQL root underscore password. Password is the environmental variable. Let me use test is the password. Now MySQL is the image name. This is a one. Docker run hyphen name mydb hyphen d hyphen e MySQL root password, and test is the image name and the MySQL. Just click on enter. It is unable to find the image locally. It will try to download the image from the hub.docker.com. Let it complete. Now, if you see Docker Docker container ls. Now, this is the MySQL container. This is a MySQL container. How to know all the different environmental variables that you need to pass in the command? Actually, go to hub.docker.com. You will be having hub.docker.com where we store our Docker images. Go here and you will be finding, search for MySQL. Okay. Now search for MySQL. Click on this MySQL and you will be finding the environmental variables that need to be passed to your Docker container like this: MySQL root password, MySQL database, MySQL user, and MySQL password, something like this. These are the environmental variables that you need to pass to your uh, container, actually your MySQL container. And this is mandatory environmental variables. You cannot run your MySQL container without this, but these are all optional environmental variables that we have in the MySQL container actually. So that's how it works. Now let me go here and that is a thing actually. How to go inside the container, using copy the container ID, this is a container ID. Now how to go inside the container? Docker exec -it container ID /bin/sh is a command. I am inside the container now. Please see, I am inside the container. Previously I am on my Docker host, but now I am inside the container of MySQL actually. Okay, MySQL container, because I've used MySQL container ID in order to enter into the MySQL. Now how to enter into the MySQL database? Okay, how to enter into the MySQL database? MySQL okay, hyphen u means username, root. Okay, hyphen p is a password. It will ask for entering the password. Just enter the password. What is the password? We have set that password while running it as a container test. Now click on enter the password. Now this is, now you can see previously here we are inside the MySQL container and now you are inside the MySQL database, and you can execute the MySQL queries here. Okay, now what is the MySQL query? Show databases. Show databases is one of the query. Okay, once again, show databases. Now this will show all the databases. Now use database MySQL. Now once again, it's not database. It should use MySQL. Now that's the thing. Now show tables. These are the all MySQL queries. No need of worrying. Now these are all the tables that are by default present in the MySQL database actually. Now clear the screen. Now exit out of this and exit. Now Docker container ls. You can see that's how that works actually. That's how you need to set the environmental variables for your container using -e. Where is that -e we have used? Let me check that. Yeah, here -e actually. Now you can also do restart of your containers. Let me show you that one. Let me clear the screen first. Now Docker container ls. If you go here, if you go to Nginx, I want to restart this container, copy this container ID, Docker restart and the container ID. Just click on enter. Now it got restarted. Docker container ls. You can see that one here. It is restarted and it is up since 5 seconds ago. Previously it is up since 14 minutes ago, but now it is up since 5 seconds ago. That means it got restarted. Now how to stop the particular container? Using Docker stop command. You have Docker stop command to stop any particular container. Now Docker stop command. Now how to list all the running and stopped containers? Docker container ls-a. Once again, ls-a once again. Container ls-a. If you see, this will show all the stopped and the running containers. You can see first three containers are in up state, that means running state, and the last container is in exited state, that means stopped state. Actually, how to remove stopped containers? Docker rm and the container id. This is the container id that I want to use. Okay, this is a container id. Now see, if this, see, we have what are the images that we have? Docker images. Okay, Docker images, we have Jenkins, Tomcat, Nginx, and MySQL image in my local machine. And MySQL, Tomcat, and Jenkins is used by these images are used by some of the containers. These three containers, these first three containers, like this here. Where is that? Yeah, these three containers are using the image or images. These three images. Actually, you cannot remove the image if it is used by any of the containers. It is, suppose I want to delete the Jenkins image. Let me put it here. Let me copy this Jenkins/Jenkins. Now, how to remove a particular image? Docker rmi is the remove image, and the Jenkins is the image name. If you want to remove this, it will show me the error. You cannot remove the image that is used by the container, that is used by the running container. Actually, so that's a thing you need to understand. But you can remove the Nginx image because Nginx image is not used by any other container. Now you can use this. Now Docker rm, and this is the rmi, right? Remove image, and the Nginx is the image name. Now I have deleted Nginx image. Docker container ls. Okay, now these are all the containers that were in running state. Now how to remove all these containers at one command? Okay, now we have something called docker rm-f, docker rm-f dollar docker one second, docker ps-aq is the command to remove all the containers at once. Actually, just click on enter. Now all the containers will be removed at once. These are the two containers that will be removed at once. Yeah, the three containers I mean to say. Now if you see docker container ls, you can see there are no containers that will be in running state. Actually, okay, that's how. Now while running this port forwarding thing, Jenkins, for that one we have used -p in the diagram. I have told you, right? -p we have used, we have mapped particular port on the Docker host to particular port on the Docker container. But we can also, we have another choice, like we can also leave Docker to decide whatever port that it should want. Actually, so how, for that you need to use -P, like that. Let me use it here. Let me put it the command here. Docker run -name is equal to web app one -d -P and nginx -d nginx. That represents, it will select any particular port on the Docker host to map to a port number 80. Actually, let me copy this command. Let me copy this command and let me run it as a container. Let me go here and let me run it as a container. Docker run once again. Docker run web app one -name. One second, I should use -name. Okay, that's how it works. Now let me complete. Is pulling the image. Now if you see Docker container ls, you can see this is the image. It did automatic port mapping 32,770 on my Docker host. If you access that port on my web browser localhost 32,770, okay, then you will be able to access the application from your web browser. That means -P represents automatic port mapping. Okay, automatic port mapping -P is that one. Okay, that's a thing. Actually, now let me clear the screen. Now what we have seen today is, we have seen different commands that we will be using in the Docker. We have seen the use cases like we have installed Nginx as a container, and we have installed Tomcat as a container. Tomcat is an image as a container, and we have seen some of MySQL instance as a MySQL database as a container. We have also seen the Jenkins as a container actually. Now we need to see the three-tier architecture that is there in the industry, and we have also seen the Docker architecture. Sorry for that, I forgot that. Yeah, Docker architecture we have seen, and you need to understand the three-tier architecture of the of that we have, that is used in the industry as well. So let me remove all these things and let me explain you the three-tier architecture. Okay, let me remove all these things. Now if you see in industry, what will happen, there will be a multiple applications in the three-tier architecture. There will be, for example, let's take, there are three different applications, that is front-end application, back-end application, and the database application. Now front-end application will be connected to back-end application using the APIs of the backend application. Let me take that one here. Backend application will be having, let me name it as front end here. One second. And let me name it as backend. And this is the database. This is a database. Now front end the request that will be coming to the all the from the users, end users, will be going to the front end application, will be from the front end application actually. Now front end application will be connecting to the back end application to perform some operations. Okay, to perform some operations. Now back end application will be connected to the database to perform CRUD operations like create, update, read, update, and delete operations on the databases. Now backend application should be connected to the database application, and the front end application should be connected to the backend application. Now the vice versa as well. The vice versa means like this database application, something like this should send the source. Once again, should send the data, and this backend also should send the data to front end. Now, in the Docker, in the context of Docker, so all the requests, the data which is fetched from the database by the backend application will be given to users through the front end application. That's how it works actually. In the context of Docker, this front end application will be one container, and this backend application will be another container, and this database application will be another container. Now what will happen in this case is, now this front end container, let me name them, let me label them, because it will be clear for you people. One second. This is a front end, and this is a backend, and this is a database. This is a database. Now what you need to understand here is, front end application need to be connected to back end application. The communication should be there between the front end application and backend application, and the communication should also be there between the backend application and the database application. That means these three are different containers in Docker. In the context of Docker, front-end container should be having the communication with the backend container to perform some necessary actions, and the backend container should be able to communicate with the database container to perform CRUD operations, and backend database container will be giving the data to backend, and backend container will be giving the data to front end actually. So, and the front end will be showing the data to end users actually. So this is the three-tier architecture that you need to understand before going further actually. So that's how the communication between should be there between the containers actually. This is a container 1, container 2, and the container three actually. How this communication will be established, actually, let me put, actually there are multiple ways, three ways I mean to say. First way is using hyphen hyphen link option, hyphen hyphen link option, and the second way is using Docker Compose. It's a Docker Compose is an automatic way, or it's a powerful tool to automate the creation of containers and perform necessary things. Compose is second way, and the third way that you need to use is Docker actually, Docker networking, hyphen link, Docker Compose, and Docker networking is these are all three ways that is used to establish a communication between the containers, actually between the containers. Okay, hyphen is a Docker Compose is a developer tool, and is a powerful tool to automate the creation of containers, to establish a communication, and to perform whatever actions we have did in the Docker in an automated manner, actually. So this communication can be established in this three ways, that is hyphen link, Docker Compose, and Docker networking, actually. So that's a thing. So now so what we have discussed today, we have discussed Docker architecture, some of the commands related to Docker, and some of the use cases, Nginx and the Tomcat and the MySQL, as well as the Jenkins use case and the three-tier architecture we have discussed. And the further what you need to discuss is you need to understand one point here. Okay, you need to understand one point here. Let me go here and remove these things, all this. Now, what you need to understand is this is a container. This is a container, actually. Until what time this container will be in running state? See, most of the containers, each and every container, the applications will be like, there is some process will be there inside the container that will be in running state. Suppose this is a container, there is some process that will be which is running inside the container. There is some particular process which is running inside the container, actually, something like this. Some process that will be running inside the container. Until and unless the process which is there inside the container is in running state, the container will be in running state. Once the process inside the container is in stopped state, the container will go to exited state or restarted state. It entirely, the up and run, the running status of the container is entirely depends on the process which is running inside the container, actually. So that's how it works. Now, there are multiple images inside which the process will be running inside them, actually, but there are a few other images like Ubuntu, BusyBox, CentOS. There will be no process that is running inside the container. That's uh, there will be no process. That's why they go to exited state. Let's take an example of Ubuntu. I want to run Ubuntu contain image as a container. Docker run hyphen name is equal to my machine. Okay, machine hyphen d detached mode, and I need to use Ubuntu Ubuntu as an image name. Just click on enter. It will not find the image locally because the Docker image is not there in my local machine, and it will download the Docker image from the hub.docker.com. Now let's complete. Now if you see Docker container, Docker container release, because the Ubuntu is not in running state. You can see we have executed Ubuntu image as a container, but it is not in running state. Why? Because there will be no process which is running inside the Ubuntu machine or Ubuntu container, because Ubuntu is just an operating system. Now let's say now you can see it went to exited state. Okay, it went to exited state. What to do if you want to run this as a container? Let me remove this Docker RM and the container ID. Now you need to use -it that represents you are mentioning the container Ubuntu image. You run what is -it? -it represents interactive terminal, actually. Now you are giving the command to the Ubuntu image, you run interactive terminal process in it. Okay, that's the meaning of that. Just let me click on enter. If you see Docker container ls, there will be the Ubuntu container. Now it is in running state because we have used -it. Now let me copy this. And let me Docker exec is the command, execute -it container id, because we have told you this command when you are executing the Docker MySQL image as a container, we have logged into the container. This command is to enter into the container /bin/sh, go inside that. Okay, I am inside the container now. I am inside the container now. I have made my Ubuntu image to run a particular process inside it. Previously it went to exited state. Where is that? Yeah, here. But when I used -it while running the command, it did not went to exited state and it is in running state. Now if you see inside the Ubuntu image, there is no git installed. Okay, let me install git. How to install git? apt-get update -y. I am updating the packages. It is updating the packages. Let's complete. Okay, this got updated the packages. Now git is not there. Previously you can find it here. Git is not there. Git not found. It is giving git not found. Now apt-get install git. Okay, this is another command. So it will try to install git. It will ask for our confirmation. Click on y, and it will try to install git operating git inside the Ubuntu machine, Ubuntu container, I mean to say. Did it complete? Now, if you see now, Git is installed now. Now, if you see Git -version, you can see Git is installed with version 2.34.1. Okay, let me remove this. Git version, you can see 2.3.1, 2.34.1 is been installed. Now, if you are a developer, what you will be doing? Suppose let's think now you need to understand, like, until and unless a process inside the container is running, the container will be in running state. Once the process is exited, the container will go to exited state. Actually, now if you go here, let me come out of this container. Docker $pq control pq is a shortcut to come out of the container. So you should hold control and click on p, click on q. That's it. Okay, now if you see Docker container ls, you can see, one second, container ls. These are the two different containers that are running. How to remove the containers at once? There is a command, docker rm -f. I have already told you, docker ps-aq is a command that will remove all the running containers at once. -f represents force and rm represents remove, and docker ps-aq gives all the container ids as an output. Okay, something like that. Let me show you that one. Docker run. So, yeah. Now, if I execute docker ps-aq, that will give the container IDs. Now, that container IDs which is fetched from this command will be passed to docker rm command that will remove all the containers with that IDs that is given by this command. Actually, that's how it works. Now, let me remove the screen. Okay. Now, if you are a developer, what you will be doing, if you want to, if you have developed any application and you want to connect that application with the MySQL database. Okay, now this is your application, whether it's any application, Spring Boot or the Python or any other application, now .NET or something else. Now, if you need to install the MySQL MySQL software in your local machine and to connect your application to your MySQL database, right? But you can also use MySQL as a Docker container. You can also use MySQL as a Docker container, and you can connect your Spring Boot application to MySQL container using the URL, username, and password, and you can try to fetch the data to perform the CRUD operations. You no need of installing the MySQL entire software in your local machine. Just create a container and connect to that container. Then the things will go for you. Actually, no need of installing software, something like that. Okay, so something like that you need to understand. Okay, now what we have seen today is we have seen about the Docker architecture, we have seen about the some of the Docker commands, and we have seen about some of the use cases, like with the help of Nginx, we have port forwarded that, we have seen the Tomcat, we have port forwarded that, we have seen the MySQL, we have logged into that, and we have executed some of the MySQL queries, and we have seen the other thing, what is that, Jenkins, and we have entered the password, and we went to next screen, and we have also seen uh, three-tier architecture, and we have seen the how the communication different ways that is there with Docker to establish communication between the different Docker containers, and we have seen different things actually. So in the next class from the next weekend, you make sure the class will be shifted to 8 a.m. morning, and the things we are going to move further with establishing a communication between the containers using hyphen link option. That's how you need to see actually. Now at the end of this class, I want to show you one of the use case of Neo4j. Neo4j is a graphical database. Go here and search for Neo4j. Let me go here. Neo4j. Okay. Now search for that. Now go click on Neo4j. Now click on Neo4j and copy this Docker run command. Copy this, and just do not worry about this hyphen volume. We did not mention as of now, but hyphen publish means hyphen p be used in the image, right? So previously we use hyphen p in the commands, right? That is the same as hyphen publish. Just copy this and go to the command prompt and click on enter. Now click on enter. Actually, now the image is not found locally. It will download the image from the hub.docker.com. Let us wait for some time. Yeah, it has been downloaded. Once again, it has been downloaded and executed as a container. Now let's access that from your web browser. Let me go here, Neo4j. Now how to access that? Localhost 747474, because the Neo4j will be running on port number 7474, and we have port forwarded to 7474 port of my Docker host, and this another port will be 7687. That is for the backup purpose of Neo4j database. Now that is the one. The password for the username, password, and Neo4j. Let me try to log in. If I'm not wrong, this might be the correct one. Yeah, I am entered into the Neo4j database. Let me go here and let me query some of the examples. Hello world, let me do this. Now you can see I have executed a command which is in the Neo4j. This commands in Neo4j is called as ciphers. Actually, this is the cipher language that we'll use, cipher queries we use to query to store the data in the data a Neo4j database, actually, something like that. Okay, so this is the Neo4j, one of the use case that I want to show you. Database, actually, something like that. Okay, so if you have any questions, you can ask. This is a class, actually. If you don't have, we'll meet on next weekend, and we'll continue with the establishing communication between the containers using hyphen link option that we have in from the different options that we have with the establishing communication. So something like that. So that's the thing. So if you have any questions, please ask. If not, we will meet on next weekend. Thank you.